Hello, this is Mr. Knowles, and this instructional video focuses on solving division problems using an area model. Earlier in the year, our class learned how to use the area model to solve multiplication problems. Now we're going to use it to solve division problems. Let's get started. Two teachers wanted to have their classrooms work on a school project together. They have 58 students in all and want to have their students, it should say, work in groups of 4. How many groups of 4 will there be? And then down below, there's an area, or there's a space. We're going to use the area model to solve the division problem. And on the right, there's a multiplication menu. So I have my students fill out the multiplication menu first, and it's going to be multiples of 4, because the 4 represents how many students are in a group, and the number on the right tells us how many groups there are. So it'd be 4 students in 2 groups. That would be 8 total students. 4 students in 3 groups, so that would be 12 total students. 4 students in 5 groups, that would be 20 total students. And we're trying to get as close as we can to what the problem is trying to answer. And I believe it's 58. Let's look up above. Yep, 58. Well, none of those are 58. I noticed 60 is really close to 58, but the number 60 is too big. I noticed that 4 times 12, 4 students in 12 groups, each in 12 groups, that'd be 48 total students. That's a good number. So let's start this area model process. So on the left side of this grid, I'm going to show or represent the number 4. I'm going to get a highlighter for a minute. And what I'm going to start doing is trying to create rectangular arrays or columns of 4. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and I'm trying to build a rectangular array or an area, a rectangular area of 58 with one dimension being 4. That's why I highlighted where the 4 is going to be, that dimension of 4. We can't go past that. Well, instead of going one at a time, 4, 8, 12, 16, and so on, we can use our multiplication menu on the right to quickly see that right here, 4 times 12 is 48. And we can just plug that in right away. 4 times 12, there's 10, there's 12. 4 times 12 is going to be 48. So 4 times 12, using the area model, inside of there is 48. How close am I to 58? Well, I might have to do a little subtraction now. So on the side, I might just do 58 minus 48, 10. I'm 10 away. So how many columns of 4 can I get within, like inside 10? And I noticed right here, 4 times 2 is 8. That's really close to 10. So I'm going to have 4 times 2 is 8. And all together, what's 48 and 8? I know it's 56. How close am I to 58? I'm 2 away. Since I'm 2 away, that's less than 4. I cannot make another column of 4. So what I'm going to do is I'm going to draw 2 little tiles or squares and put an R2. And that represents remainder 2. That's what I have left over. And they kind of look like they're dangling there because they're not part of a column of 4. And that's significant to me as a mathematician because that's a remainder. Well, now I just have to add this up on top. So 10 plus 2 plus 2, that's 14. And then I can include my remainder 2. So the answer to this division problem is 14 remainder 2. But what's the answer to the question up above? It might be different than the answer to the division problem. The question is, how many groups of 4 will there be? Well, that's right here. There's going to be 14 groups of 4. So I'm going to write that here. There will be 14 groups of 4 and 2. See the 2? There's going to be one group of 2 and one group of 2. Let's try another one. Mrs. Larson has 50 little erasers. She wants to divide the erasers evenly among 3 students in her reading group. How many erasers will each student get? All right, well, there's 3 students, so I noticed that Mr. Knowles provided me with a multiplication menu for 3. I'm going to solve those basic facts. 3 times 2 is 6, 3 times 3 is 9, 3 times 5 is 15, 18, 21, 24, 27, 30, 36, 45. I hope I'm right. Sometimes I'm wrong. So now I'm going to build an area model to represent this division problem. So I'm going to put the 3 there. And I'm just doing this highlighter part just for you as a visual so that you know you can't go past those lines when you're building these columns of 3. And I'm trying to get a rectangular array of 50. So I'm going to look at my multiplication menu, and I noticed 3 times 15 is 45. That's really close to 50. So I'm going to go ahead and draw a 10 here and a 5 because that's 15. And I'm going to go ahead and put in a rectangle like that with the dimensions of 3 and 15 because 3 times 15 is 45. And 50 minus 45, I think you guys already know, is 5. I'm 5 away. How many more 3s, how many more columns of 3 can I put into the number 5? I can only do one more because I noticed that 3 times 2 in my multiplication menu right here is 6. So 3 times 1 is going to fit within the number 5. So I'm going to put a 1 here. 3 times 1 is 3. And 45 and 3 together, that's 48. How close am I to the number 50? I'm 2 away. Well, I got to put in 2 little squares or tiles And that's going to be a remainder because it does not complete a column of 3. So I have a remainder of 2. So all I have to do now is add this up here. Those are all my complete columns of 3 that I could put inside the number 50. 10 plus 5 plus 1, that's 16. And I do have a remainder of 2. That's the answer to the division problem, but is that the answer to the question? How many erasers will each student get? Each student's going to get 16. Each student will get 16 erasers. There will be 2 left. All right, let's try one more. Frank had 64 shells that he wanted to share with his 4 friends. If he gave each friend the same number of shells and kept the same number of shells for himself, how many shells did each person get? All right, well, I noticed that Mr. Knowles has a multiplication menu for 5, but wait a minute, there's 4 friends. I think he made a mistake. Sometimes he makes mistakes. Yep, I see there's 4 friends. I wonder why he did that. We'll have to tell him. 4 friends. If he gave each friend the same number of shells, oh, wait a minute, and kept the same number of shells for himself, well, that'd be 5 people. 5 people are going to share these shells. So I see why he has a 5 there now. Okay, Mr. Knowles. Underline that 64 there. I'm going to do my multiplication menu quickly of my 5s because I know them pretty well. I hope that you do too. And I'm going to set up my left side, my dimension of what this rectangle will be. I'm going to put a 5 here. And I know that I have 64 shells that I'm trying to put inside my rectangular array, my rectangle. I'm just going to do this for you as a visual so you know I can't go past that. And I'm building columns of 5. And I noticed 5 times 12 is 60. Well, that's a good one because that's almost a 64. So 5 times 12, well, that's a 10 and that's a 2, and altogether that's 12. So 5 times 12, all that is 60. I'm only 4 away from 64. I think I already know what my remainder is because I cannot build any more columns of 5. I have a remainder of 4. So I just have to add that up. It's 12, remainder 4. So that answers the division problem, but does that answer the question? What's the question? How many shells did each person get? Well, they each got 12. Each person got or gets 12 shells. If you want to say a little more, you could say there are 4 left over. Or there are 4 left. I hope this has been helpful to you. If you have any more questions or you need a little extra support, please let me know. Thanks.